Welcome. My name is Joseph Lombardi. This is my first ever DevOps related video that I'm posting on YouTube. I have over 9 years of IT experience, with the vast majority of them being in the MSP space. And I was recently able to successfully pivot into the DevOps space. This is going to be a two-part video. Really, the main focus of part one here in this video is to get an understanding of what we're doing behind the scenes. I firmly believe that before you try to automate anything, you really should understand what's going on behind the covers and under the hood. And once that's established, then go ahead and automate. So that's really going to be the focus of this section or this video. It's going to be focused on really getting an understanding of the concepts. The only thing that we're going to be automating in this video is going to be spinning up the VPC, the Virtual Private Cloud in AWS. We will be using CloudFormation for that. And of course, Ansible itself is an automation tool. But everything else will be done manually through the AWS console. Part 2 will cover automation of that. All of these things that I talk about in this video will be automated in part 2. I'm really passionate about this topic because I feel like this is sort of a marrying of my previous life with my new life in IT. I dealt with a lot of Windows servers in my MSP experience, and this is sort of melding DevOps into that Windows space. And I hope that this video will be helpful for anybody that has sort of a similar background. Maybe not a traditional developer background, but maybe a sysadmin or a Windows Server administrator background. So we have a lot to cover. This is the agenda. Very first thing that we're going to do is we're going to provision a VPC, a virtual private cloud, in AWS. Second, a Bastion host will be set up, so we have an entry point into AWS. Then I'm going to spin up a RHEL 9.5 server on EC2. 9.5 is the latest version of RHEL at the time of this recording. On that RHEL server, we're going to install Ansible and EPEL extra packages for enterprise Linux. That's a prereq before you can even install Ansible, so I'll cover that. Then we're going to switch back into Windows land and install Server 2025, a DC, and a test server. The test server will be the server that will be used to domain join using Ansible. We'll also talk about collections. In order for all this to happen, we have to have both the Windows and the Active Directory collections installed on the Ansible server. We'll prepare Windows for Ansible connectivity using a PowerShell script, and we'll create a security group rule to allow inbound secure WinRM from the Ansible server. I'll show you how to create and configure AWS access keys that will be stored on the Ansible server. Then we'll create an inventory file, an Ansible inventory file, test connectivity to Windows from Ansible using WinPing, write the Ansible playbook, and add some additional security group rules pertaining to AD. Then I'll run the Ansible playbook and perform some troubleshooting as needed. We'll end the video demo with showing you how to encrypt credentials using Ansible Vault. And the video will end with parameterizing a playbook, introducing variables so that the playbook can be reused across dozens of domains, dozens of OUs, dozens of host names that are all different. And we'll wrap up. So get ready. This is going to be a ride. Here we go. The first thing that we need to do before we do anything with this demo is we need to spin up some infrastructure in AWS. We need to spin up a virtual private cloud or a VPC. We could go through the process of walking through the GUI in AWS, but for the sake of time, and for those that haven't seen CloudFormation as an infrastructure as code tool, you'll see how powerful it is. What I'm going to be using is a template by Tom Gregory, and we're going to modify it a little bit. We're going to strip out a couple of the, like, he's got 2 public subnets and 2 private subnets. We don't need all that. This is just for demo purposes. So this is not, as a disclaimer, this is not a video, a deep dive of VPC or high availability or DR. We're just getting the bare infrastructure necessary to really get to the meat of what this video demonstrations is about, and that's about Ansible and managing Windows within Ansible. So the video is called Create Public and Private Subnets in AWS VPC to Secure Your Containers. This is a video by Tom Gregory. We're going to actually download the template that he used, and we're going to open it, and we're going to make some modifications. Okay. So the first thing that we need to do is we're not going to create multiple public and private subnets. We're going to just create one public and one private subnet. So anytime we see 2, we're just going to remove this, get rid of it, and then we're going to remove the second subnet as well for the private subnet. We don't need 2 elastic IPs, so we're going to get rid of that. We're not going to need 2 NAT gateways, so we're going to get rid of that. We're not going to need a route table subnet association for the second public subnet. It's not necessary. So anytime we see 2, we're going to eliminate that. Get rid of this. Get rid of this. We don't need this or that. 1 public, 1 private subnet, 1 NAT gateway, 1 internet gateway. As simple as you can make it. It's about 100 lines of code. A couple changes that we need to make to this, just for sake of being able to identify it. So we're going to actually change this to my VPC. And we're going to change this to my internet gateway. And then in addition to that, that looks good. We're going to call this public subnet 1. We're going to call this private subnet 1. That looks good. We're going to call this public route table. call this private route table. So we're modifying this to fit our needs. That looks good. We don't need this. Just going through it real quick. So a couple things we want to add. We want to be able to identify the NAT gateway and the internet gateway so that when you view it in the console, it's not blank for the name. We want to be able to easily identify that. So for NAT gateway 1, we're going to actually add some tags here with a key of name and a value of my NAT gateway. And we're going to do the same for the IGW, the internet gateway, that's already factored in. Okay, that looks good. This looks good. Okay, so what we're going to do now is we're going to save this and we're going to upload it into CloudFormation. So we're going to go to our AWS console. We're going to go to CloudFormation. So that's available by just going to CloudFormation. We're going to create a stack, choose an existing template, upload the template file from our downloads. It's this one. We're going to call it myVPC as the stack name. We're going to skip all this stuff. And we're going to submit. And for those that are just seeing CloudFormation as an infrastructure as code tool for the first time, you're going to see how powerful this is. So I had to modify that YAML file, which was pretty easily readable, but meanwhile, it's creating all these resources. It's already creating 9. So 1 private subnet, 1 internet gateway, 1 NAT gateway, 1 public subnet, an elastic IP, and then a private and a public routing table. So we're keeping it as basic as possible. What's going to probably take the longest amount of time for this is the NAT gateway creation. So just to recap, internet gateway allows your public subnet access to the internet. Your NAT gateway allows your private subnet access to the internet. And we'll examine those entries and the route tables for private and public once this is 100% complete. See, we've already got 12 resources created. Didn't have to go through the console and click and manually go into each section and painstakingly do all of the configurations. We will be using Terraform to spin up infrastructure and automate some of the infrastructure later. But this is a good proof of concept of CloudFormation, and we just want to spin up the VPC, and we know that this template works, so it's a quick way to do it. Okay, we are done. Everything is provisioned. So if we go into our, if we go to VPC, which we're already there, we'll go to the dashboard, and we should see, if we go to VPC, we'll see my VPC that was created, okay, with the 10.0.0.0 CIDR. We'll see the private and public subnets that were created. These other 6 are default. So I'm in US East 1, so it's going to create 6 default ones. But this helps you identify what we created with the CloudFormation stack. With the route tables, we can see we have a private and a public. And if we go into the route table, we'll see that the private points, there's a route for the NAT gateway right here. And then the public actually points the quad 0 destination to the internet gateway. Okay, so that looks great. We'll see an internet gateway, my internet gateway. So that's the key value, the key, the name, and the attribute that we added so that we could identify it. If we did not add that, this would just be blank. So that's why we added that and modified it. And then the same goes with the NAT gateway. It has a name as well. So we're all set. We have infrastructure now, and it is provisioned. Now that a VPC has been spun up with private and public subnets, we need an entry point into AWS. We need what's called a Bastion host, also known as a jump box, as a single point of entry into the infrastructure. Now, we are going to put this Bastion or jump box into the public subnet, so it will have a public IP address. But this is going to be the only server in this lab demonstration that will have a public IP address. We're going to try to simulate a production environment as close as possible. It won't be exact, but it'll be close. So we obviously don't want all of our instances having public IPs. So that's what we're going to do right now. We're going to spin up a Windows Server 2025 Bastion host, and that will be any work that we do in the labs. We will be RDPing into that server, and then we will use that to RDP and or SSH into the other servers that we build. So let's go ahead and spin that up. So I'm on the EC2 console right now. So to get here, you type in EC2. And click Instances, and we're going to launch an instance. And we're going to call this Win 2025 Bastion. We're going to select the operating system as Windows. 2025 base, that's fine. Some of you may be aware that base in earlier versions of Windows would just indicate, hey, this is just like PowerShell, there is no UI or GUI installed. That's not the case here. So with base, you're actually getting data center. So you will have a UI, not to worry. So server 2025, we are going to select T3 medium. We don't need a workhorse, but we also don't want something that's going to be terribly sluggish either. So this fits the bill. This will be just fine for our demonstration purposes and to kind of keep costs down. We are going to need to create a key pair. So we're going to create a new key pair here. And we're going to use this key pair for both Windows and Linux in this demonstration. So we will name this AWS key pair. We're going to keep the default of RSA. In fact, this isn't even selectable as an option, so you don't have choice. And we're going to keep the default PEM file, a key file format. And the reason for this is that it's going to be allow us some flexibility in terms of using the same key for both Windows and Linux servers. It does say that PPK is an option for PuTTY, or if you're using Windows, but to be honest with you, PEM is supported by Windows too. So we're going to use PEM. We're going to click create key pair. So that's been assigned. And then we're going to modify the network settings. So we're going to click edit. And we do not want this in the default VPC. We want to actually select the VPC that was spun up via the CloudFormation template. So my VPC. And as mentioned before, this is going to be the only server that's in the public subnet. So you see public subnet and private subnet that was created as part of the CloudFormation template. We're going to keep public subnet selected. We're going to select a security group. If you don't select the default security group when you spin this up, it's going to create this launch wizard 1, which over time, it's going to be hard to know, like, just for the naming convention, what launch wizard does what. So for now, we're going to select the existing default security group. We are going to remove it later, and we're going to create a public security group. So this is just temporary. We're going to keep 30 gigs worth of space. That's fine. We don't need a lot of space on this. This is just an entry point into AWS, a jump box. And then we are going to click on Launch Instance. So once that's done, we're going to click on the instance. And you may have noticed that the key is actually in the downloads. We're going to actually rename the key because I already re-recorded this demo, and we're going to just rename this so that we're not confused as to which key we're using. I'm just going to call this AWS key pair. And while that's initializing, we can do something straight away. We can modify the security group, create a public security group, and then add your home IP to allow it inbound for RDP. So that's what we're going to do right now. So we're going to go to security groups, and you'll see just the default are here. So we're going to create a security group, and we're going to name it public SG. And we'll actually use the same name as the description. And we're going to specify my VPC. Very important to select your VPC when you're creating the security group, because you may be like, hey, why is my security group not showing? Well, it may not be in the right VPC. So it's important you don't skip this step. And we're going to allow an inbound rule for RDP. So we're going to select RDP for inbound rules. And this next part I'm going to actually blur out because I don't want, for obvious reasons, I don't want my ISP address to be known. So one way you can find out what your IP address is from your internet service provider is just type in IP chicken. So I'm going to blur the screen, but I'm going to copy the IP address from this screen, close this out. And for the source, I'm going to actually paste in the address, and then just don't forget to add a /32 at the end. So a /32 indicates that it's a single IP address. And in the description box, I'm going to specify allow RDP from home. I'm going to leave the outbound as allow all traffic, anywhere. I'm less concerned with what's called a quad 0 being in an outbound role, especially in a public subnet, than I am obviously with a quad 0 being in the inbound roles. So we're going to leave that as it is. And then we're going to create the security group. And once that's created, I'm going to go back to that instance that we launched. And you'll notice the status checks are ready. So once we change the security group, we're going to RDP into this Bastion host. So select the instance. We're going to go to Actions, Security, change security groups. We're going to remove the default one, and we're going to add the public security group that we just created. Add, and click Save. So now, if we go to the security group, we'll notice that public SG is now attached as a security group, and the default's been removed. So with that being said, and with the status checks being 3 out of 3 passed, we're going to grab the public IP address from the details. We're going to copy it to the clipboard, and we're going to open up RDP. So I just type in RDP in the search bar, drag this over, and just paste in the IP address, and click Connect. Okay, under More Choices, we're going to use a different account, and we're going to use the administrator account. Okay, so on a separate window, I've opened up a blank notepad box, and what we're going to do is paste over the administrator password that we get once we obtain it. So let's kind of click out of this for now. To get the Windows password, you simply just right-click, hit Security, hit Get Windows Password, and you'll see Upload Private Key File. And so we're going to upload the private key file that we downloaded just a moment ago. You'll see the private key has been generated down here, and we're going to click Decrypt Password. And I don't care if the password is displayed here. I'm going to delete this key as soon as this video uploads, so it won't be of any use. So I'm just going to copy this password, and over on Notepad, I'm going to paste it, just so that it's easy to keep track of for this demo. So I'm going to copy this password, and we're going to resume that RDP session that we had, and we're going to click Paste and OK. And for the security warning, we're going to click Yes. And that's it. So if you've never seen Windows Server 2025 before, it looks just like Windows 11. It's sort of a common pattern where the Windows Server version sort of ties with its corresponding client OS version. So no real big surprise there. The very first thing that we're going to do once we see the desktop screen is we're going to change the host name to reflect what's in the AWS console. So this is our Bastion host. This is what we're going to use to both SSH into the Ansible server once we set that up, and also to RDP into the domain controller, and then the test dummy Windows server that we're going to use Ansible to domain join. So let's change this host name. Also, I'm going to change the time because it is way off. So let me do that too. So I'm going to go enter time into the search box. And I'm in Eastern Standard Time, so date and time settings. So as you can see, this is not a speed daemon, but it's fast enough to be able to get tasks done. Time zone. Specify Eastern Time. And it's currently midnight where I am, or a little after midnight. And then also under System, I'm gonna I'm gonna go out of here, right click Start, go to System. and I'm going to click rename this PC. And I'll name it what was the name tag in AWS, just so it's consistent. In 2025, Bastion. Next. And we're going to obviously keep this in a work group. Restart now. Continue. We'll lose our RDP access when it's rebooting. And yeah, so that is the Windows and their backgrounds. Once that's done, we will have the PC renamed, and that'll be our entry point. When we SSH into Linux servers, and when we RDP into Windows servers, like the domain controller, we'll use that as a jump box. You obviously don't want your domain controller to have a public IP address, or your Ansible server for that matter. So that's done. One final note here before we proceed to be aware of is if you spin up a server in a public subnet, whenever you turn the machine off, it will get a new public IP. The public IP will change. In order to prevent the public IP from changing, that's what elastic IPs are for. So you can keep the same public IP. For this particular lab, we don't necessarily need the IP not to change. So not so bad, but like if you're using a pipeline, you probably want to keep that IP the same. Now that we have a Bastion host set up in the public subnet, the next thing that we're going to do is spin up a Red Hat Enterprise Linux RHEL 9.5 server in the private subnet. We're also going to create a private security group that will allow us to be able to SSH from this Bastion. So it's actually going to be easier to perform this work while inside the Bastion, because we're going to have to, we'll create a new key pair. We'll call it a private key. And we're going to need to download it locally to that machine. You can't really copy and paste from my local machine to the Bastion host, so it's just going to be easier to do it from inside the Bastion. So let's grab the IP, the public IP, and we're going to RDP in to the Bastion. We're going to copy over the password, click OK. Okay, and because this is in a public subnet, the public subnet is directly attached to an internet gateway, so we have internet access. So if I open up Edge here, because it's the first time I'm opening Edge, it's probably going to have a bunch of questions. I gotta, skip syncing. No, don't send my data, or data to Microsoft. Start without your data. No, we're not bringing over anything from other browsers. Continue without your data. Nope. Confirm and start browsing. So let's go to the AWS console from inside this Bastion. So we're going to do it from here. One thing that I'm going to do is I'm going to change this to dark mode. I don't know about you guys, but maybe it's just an IT thing. But anytime there's a dark mode available, that's my go-to. So dark. Yeah, that's much better. Easier on the eyes. So let's spin up this EC2 instance from this Bastion. So go to Instances. And we're going to launch an instance. And let's call this Ansible server. And we're going to be using Red Hat Enterprise Linux, RHEL version 9, 64-bit. We'll use a T3 medium. Is good. And so we can't, without copying the key over from my personal machine to this Bastion host, I'm going to have to create a new key pair because I have to set up additional networking to be able to allow that to happen. So create new key pair. And we're going to actually call this, because we're going to use this key for multiple servers in the private subnet, we're going to call this AWS private. Keep RSA and PEM. And that key pair is going to download locally to the downloads. So you can see now why I did this within the Bastion. We're going to select an existing security group, and for now we're going to select the default. Oh, you know what? We have to specify the VPC. See? That's a gotcha. So click Edit for Network Settings, specify the VPC, my VPC, that was created through the CloudFormation template. And you'll notice public or private. We're going to choose private in this case. And for security groups, we're going to select the default for now. You can see there's a public one, but we actually want to create a private one later. So we'll just assign the default for now. We don't need any advanced network configuration settings right now, but we will change the drive size to 30 gigs. And that'll do it. Let's launch the instance. So let's go to the instances. We'll see that the Ansible server is initializing. So let's go to the security groups. And we're going to actually create a security group called private SG. And we're going to add an inbound role to allow SSH from the Bastion, the Bastion's private IP. So how is that possible? You've got a private subnet and a public subnet. Before we proceed further, let's actually open up the VPC, and I'll show you. So we just opened up VPC in a new console. So you'll notice in subnets, there's a private and a public subnet. And both of them, so the public subnet is in 10.0.0.0/24, and the private subnet is in 10.0.2.0. However, if you look at the route tables, even though the /24 specified, the private route has 10.0.0.0/16 as local. So that means that these two route tables can communicate with each other. Okay? And the same goes with the public one. You'll see there's also a route for a /16, even though the actual subnet itself is a /24. So if we go back here to the security group that we're creating, we're going to SSH into the server, which is the Bastion. So easy way to do that is let's open up command prompt. Let's do an IP config. We could also get it from the console too, but this is just as fast. So we're going to copy that IP, and we're going to include a /32 because it's one IP that we're using. And we're going to call this for a description allow SSH from Bastion. Okay. We can leave outbound as quad 0. Not as concerned as with a quad 0 being an outbound roles. And that'll do it. So one trick here to learn to kind of demystify the whole inbound versus outbound. Inbound answers the question from where. So we are SSHing from the source being the Bastion. Outbound answers the question to where. So we're not trying to SSH to the Bastion, where the destination is, right? Where this security group that'll be attached to the Ansible server is allowing SSH from the Bastion. So I hope that helps demystify that. Once you kind of get that, it's pretty clear. Let's create the security group. Oh, I gotta give it a name. And then create the security group. So now let's go back to the instance. And let's right-click on the Ansible server. Go to security. Change security groups. Let's delete the default. And under security groups, we'll see there's a private security group. So let's select that and add. And then click Save. So now we should be able to SSH into the private IP of this Ansible server. So one helpful trick here is if you click on the Ansible server, and now that it has passed the status checks, and you click Connect, if you go to the SSH client, it gives you a cheat. This is the command you need to run for the private IP. Okay, so we're going to copy this, and then we're going to open up command prompt. Let's clear the screen, and let's change into our downloads folder, because that's where the private key, the PEM file, exists. Let's clear the screen again, and let's right click to paste that SSH command. And there we go. We just have to verify that we want to continue connecting, and we're in. So we're using this Bastion to SSH into this soon-to-be Ansible server. So now we're in. Now to verify what operating system that we're running and what version, you can run a cat etc os release, and it'll say Enterprise Red Hat Linux RHEL 9.5. So there you go. We're using the Bastion, but this is demonstrating that, hey, we're able to SSH into this Linux server even though it's on a private subnet. Okay. Okay, so let's install Ansible, shall we? So we are still in our Bastion host, and now we're going to run a series of commands, and I'm going to actually open up a notepad, just because it's a good idea to be able to keep track of the commands that you use, because eventually you're going to want to automate this. So the commands that you run are essentially going to form your bash script. So the very first command that we're going to want to run on any fresh server, or it's a good practice to do, is we're going to run a sudo yum update y. And the y is just, run it in non-interactive mode, so you're not having to press yes to continue the installation. So we're going to update the yum repository. And there it goes. So there shouldn't be too many packages to install, because RHEL 9.5 just released maybe a couple weeks ago. So as you can see, it's not this shouldn't take too long, so I'm not gonna have to pause and skip. But we'll let this run. So that was the first command we ran, was sudo yum install y. Just make sure that was what we ran. Sudo yum update, I'm sorry, y. Okay, and we're going to let that finish, and it's just about finished. Okay, while that's finishing up, we're going to open up Google in another tab here on this Bastion host. And we're going to search for RHEL install Ansible. And it should be this second, or this third option right here. Yep. And what we're going to do, this is not the right one. This one. Okay, so you are forwarded to Ansible documentation, and what we're going to do is we're installing Ansible on RHEL. So we're going to click that option. Now, on RHEL, use yum. Now, if we try to run this command, right, we're going to get an error. And there's a reason why. So as you can see, the yum update command was successful. The reason why, let's just run the command and I'll explain it. So if we run this command, yum install Ansible y, no argument found. So the reason for this is because no match for Ansible. We need to install something called extra packages for enterprise Linux. And if you actually go to this link right beneath it, or actually it says right here, RPMs for current supported versions of RHEL are available from EPEL, extra packages for enterprise Linux. So if we go to this site, it'll explain what it is. And what we're looking for is EPEL 10. So, long story short, if you go to here, and you go by 8664, you're going to get this page, and it's going to not really help very much. Like if you go under packages, like you're like, okay, well, how do I install this? Well, let's open up a new tab, and let's search for install EPEL 10 on RHEL 9. And we're going to go to this site here. And what we're looking for is this command. Install the EPEL RPM. So we're going to highlight this command. And we're going to go back to our SSH session. We're going to paste it in. And we're going to do a Y. And there it goes. EPEL is installed. So now that EPEL version 9. So now that that's available, now, well, first of all, before we continue, let's add this command to our list. We don't need the slash because we're going to make it one line, but we are going to add a Y here. So this installs EPEL. This updates the repository. This updates EPEL. Now, if we run this command, sudo yum install Ansible with a Y, okay, it should succeed. So let's clear the screen. Let's right-click to paste, sudo yum install Ansible Y. Now it's looking at the extra packages for Enterprise Linux, which wasn't available before. So now that that's there, it's looking there, and it will find Ansible as an option to install, and it's going to install it. There it goes. Just give this a moment to finish up. And once it's done, we'll enter a command to verify that Ansible is in fact installed. Now, what's making it possible for us to be able to download packages right now is there is a NAT gateway attached to the private subnet. So we are allowed internet access to be able to download things through that NAT gateway. So let's clear the screen and let's type in Ansible --version. And there you go. Ansible is installed. With Ansible installed, there are a few other things we need to do on the Ansible server. So we need to install what's called a collection. We'll need to install a Windows collection and an Active Directory collection so that when we write our Ansible playbook in an upcoming section, that those modules will be at the ready. So we're going to install those two collections for Windows and for Active Directory, and then we're going to install something called WinRM. WinRM is the primary method for Ansible to be able to communicate with Windows. So we're going to do those steps next. So let's open up Google, and we're still on our Bastion host. And we're going to go Ansible Windows collection. And it's the very first thing that comes up, Ansible Windows. And this is the Ansible documentation, official documentation. One little trick here is, in order to actually see what the command is to install this particular collection, you actually have to go into one of the modules. So for Windows, doesn't really matter. We'll go into the DNS module. And then right here it tells you to install the collection, run this command. And that's exactly what we're going to do. So we're going to highlight this command, Ansible Galaxy Collection, install Ansible Windows. We're going to go over to our terminal. Now that we have verified Ansible is installed, we're going to paste it, and we're going to install the Windows collection for Ansible. There it goes. Ansible Windows was successfully installed. So now we're going to add that to our command list. So at the bottom of here, we're going to add that command. And not only that, but we also need the Ansible Active Directory collection as well. So Ansible Active Directory. Microsoft.ed, that's it. So, Ansible collection for Active Directory management. So we're going to scroll down and we're going to follow the same process. We're going to just go to one of these modules. We'll select the membership module, and it gives you installation instructions right here. So to install this module, run this command. So that's what we're going to do. We're going to copy this, go back over to our Ansible control node, paste in that command, enter. Microsoft AD was installed successfully. So now we're going to add that to our soon-to-be bash script. And that takes care of those two collections. So then the final thing we're going to do on the Ansible server for now, before we head back into Windows land, is we're going to install WinRM. Now, WinRM, if you type in install WinRM on RHEL, you actually have to do it through pip. So you're gonna, if you type in install WinRM pip, you're gonna get the pipe.org site. So if you go there, it'll actually give you, this is the command that you need to run. Now, very much like when we tried to install Ansible, EPEL was a prereq for that. If you try to install WinRM by just running this command, we clear the screen, and we try to run that command to install WinRM, Python library for Windows Remote Management, it's going to say pip's not found. So now we have to install pip. So let's do that. Let's go to Google. So there's a few different ways to install pip. You could use DNF, you could use yum. We'll use yum for this particular one. So what we're going to do is, sudo yum install pip python 3 pip. So we're going to actually specify python 3. So we're going to copy this command. But we're going to add 3 to it, just because it's the most recent version of Python. Install python 3 pip. And we're going to do a Y at the end. There it goes. So pip is installed. So now we're going to add this command to our list of commands here in our bash script. And now, if we go back to the Pipey website to install WinRM, now we can with pip. So let's copy this command. Let's clear the screen. Let's try to run the pip install WinRM command. And there we go. Successfully installed WinRM through Python. For those that don't know, pip is a Python package manager. Just like Maven is a package manager for Java. So there we go. We have the Ansible collections for Windows and for Active Directory installed, and we have pip installed, and we have WinRM installed. So now we're going to put Ansible aside for now, and we're going to go back into Windows mode so we can spin up the domain controller and the test dummy server. So now I'm going to spin up a 2025 Windows server as a domain controller and as a DNS server in the private subnet. Obviously, you would not put a domain controller in a public subnet, so we're going to be emulating as close as possible to a production environment. Right now we are logged in to our Bastion host, and we're signed into the AWS portal. You may also have noticed that the public IP address has changed. That's because there is not an elastic IP associated with this Bastion host. For our lab, doesn't matter if the IP changes, so we'll proceed accordingly. So we're going to go to EC2, and you'll see right now we have two servers spun up in EC2 right now. We have the Ansible server and the Bastion host. I do turn off resources when they're not in use just to save on costs. So I would advise doing the same just so that your bill is reduced at the end of the month. And I'm going to click on Launch Instances. And we're going to name this server DC 2025 and just put an 01 at the end just in case. You know, for this lab we're not going to spin up a second domain controller, but that way if you do, you have like a numbering system in place as part of the naming convention. So DC 2025-01, select Windows, Windows Server 2025 base. This is going to be very similar to the setup of the Bastion host. So this should all look familiar at this point. Data Center Edition. The instance type I'll specify as T3 medium. And for the key pair, we're going to use the private key that was created earlier. And you'll notice, hey, well, we used the private key on the Ansible server. That doesn't matter. The PEM file supported on Windows or Linux, so we'll use the same one. Under network settings, we're going to specify the VPC as my VPC that was created as part of the CloudFormation template. And for subnet, we're going to specify the private subnet. Select existing security group. We're going to select the private security group. We'll give this 30 gigs of space. That's fine. And that's it. We'll click Launch Instance. So one thing that we can do while this is initializing is I'm going to modify the private security group so that it allows RDP from the Bastion. There's your keywords again. With inbound rules, it's from where, and outbound is to where. So let's go to the security groups, and I will go to the private SG, and you'll see there's already a rule for SSH. We need to add one for RDP, but we're going to also use the same Bastion private address. So let's click Edit Inbound Rules. We're going to add a rule for RDP, and we're going to use the same private IP as the Bastion host. Allow RDP from Bastion. Save rules. And there's that. So let's go back to the instance. and it's still initializing, but one sort of shortcut that you can use is you can right-click on the instance, and if you go to Monitor and Troubleshoot and Get Instance Snapshot, you can see whether the instance has the Control Alt Delete screen, and it does. So we can RDP into this. But before we do, we need to get the Windows password. So let's do that. So one important note is that if two instances use the same private key, just because they're using the same private key, or key pair rather, the passwords are going to differ. So that's a gotcha. If you're trying to, like, if I try to use the, it's a different key, obviously. The Bastion is a different key. But if I were to use the same key, I could not expect that the password that I have already pasted in Notepad is going to work on this instance. It's going to be a different password. So why don't we do that? Let's go back to the instance while it's initializing. And we're going to right click it, and we're going to get, we're going to go to security and get Windows password. And it's a different private key, so we're going to upload the private key under downloads, decrypt the password, and we're going to copy that password. So now I'm pasting that into Notepad just for ease of access. Click OK. And what we're going to do now is we're going to copy the private IP of the domain controller, and we're going to attempt to RDP into it. So I'm going to type in RDP. Paste in the IP of the domain controller, the private IP. Click connect. And we're going to do more choices. Use a different user. Administrator. And we'll paste in the password from Notepad. Click OK. And click yes at the warning. The very first thing that I'm going to do is I'm going to change the name of the server. Because if you try to open up the server manager now, it's going to use the default name of the EC2 Amazon prefix. So we're going to change the name of the server, and also I'm going to set the IP information to be static, because that'll be another thing that'll come up in the wizard, that it relies on a static IP address. So we'll walk through that process. Okay, so you'll see on the DC, but here's the Bastion, here's the DC. I'm going to click Start, and I'm going to right-click on it and go to System, and we'll rename the PC immediately. Rename this PC. You'll see the Amazon device name. And let's just make sure, I'm going to minimize this session. I'm going to make sure it's the same name. So we'll name it the same. So the tag name reflects what the computer name is. Click Next. Restart now. Continue. Okay, RDP just disconnected. We're going to give that a second to reboot. It won't take long. In fact, I'll try now. Paste in the password again. Click yes. Oh, it's shutting down. So again, we can look at what the instance is doing. So if we right click on here and we go to monitor and troubleshoot and get instant snapshot, we can refresh the screen to get an idea of what, oh, okay, so it's ready. So let's go back to RDP, paste in the password, and the session should be ready. Another thing that I'm going to do immediately is change the time. And once we change the time, I'm going to set the IP statically. So go to search, and I'm going to enter time. You'll see the host name actually reflected the change too. There's a little bit of a delay. It's not going to be immediate. And we'll change the time zone to -5 because I'm in Eastern time. And it's 11:30 here right now. So now that the name has changed and the time has changed, I'm going to set the IP to be static. Now, if you go to Start and you go to Settings, there is a way to change the IP. If you go to Network and Internet and go to Ethernet, and it's sort of a new interface. So you can specify, you can edit the IP assignment. One way to know what the existing IP information is we'll open up a command prompt. And I'm going to do an IP config all because I want to include the DNS information. If we just did IP config, it's going to give you the IP, the subnet mask, and the default gateway. But I want the DNS information because that'll tell me, hey, I'm using the AWS DNS server. When we install Active Directory Domain Services, ADDS, and DNS, this is going to change to be the loopback or its own address. So, as I mentioned, you can do it here, but I'm going to do it the old school way just because of familiarity. So I'm going to actually, in the search bar, I'm going to type in view network connections. Yep. And we're going to put this box over on the right hand side, and we're going to keep this on the left. Double click on Ethernet, properties, IPv4, and I'm going to set the static address for the IP address and the DNS and all this information. So we're going to reference this information. So I'm going to specify the IP address, copy it. Oh, 10.0.2.199. And it actually is 255.255.255. Default gateway is 10.0.2.1. DNS server is 10.0.0.2. And if we click OK, it's going to, doing a manual change like this does disrupt network connectivity, so expect to see that the RDP session is going to sort of time out, but we will be able to log in because we're essentially copying the same exact settings as it's currently using. We're just setting it statically. So this is the same, that's the same. We're specifying the default gateway and then the preferred DNS server, which is the AWS one right now. So click OK, and we are going to lose network connectivity right now. In fact, if you try to click on anything, you can see it's got like a little circle here. Just wait for it to, yep, there it goes. So then it will reconnect. And we're back in. So now it's set statically. In fact, we can confirm that by going to the new UI version of this. So if we go to Start, we go to Settings, and we go to Network and Ethernet, you'll see that IP assignment is now manual. Okay. So now we're ready to install Active Directory domain services and DNS as server roles. So I'm going to open up, just make sure we're in the right box. Yep. CL1. I'm going to open up Server Manager. And when you first open this up, it's going to say, hey, use the new experience. I'm familiar mostly with Server Manager, so I'm going to, and it's still available, so I'm going to opt for that method. And there's the try Windows admin, so don't show this again. We're going to proceed with Server Manager. I have to wait for this to sort of populate. You can see the progress bar up here that's kind of going like this. That's just kind of indicating, hey, it's still collecting information. We can try to select add roles and features, but chances are, yeah, it's collecting inventory data, so you can't do anything yet. We'll give it just a moment. Add roles and features. Okay, so we're ready. So let's skip the before you begin. We can just click next here. We're going to be using a role-based installation type because we're not installing RDS, not to be confused with AWS's RDS, which is a database service. This is for terminal server, so that doesn't apply here. So role-based or feature-based installation. And the only server that we have right now is the DC, so we're going to select that server. And for server roles, I'm going to select Active Directory Domain Services, ADDS. We're going to add its associated features. And in addition to that, we're going to select DNS server. And we'll add those respective features. So, and you'll notice that file and storage services is also included here. And that's sort of by design because there's some AD or related shares that are available. So in order to facilitate that, you have to have this role or part of this role installed, and you can see it's just storage services. So we'll click next. I'm not going to install any additional features, so we can actually skip through this screen. And these next series of screens just kind of give you an information about the respective server role that you're installing. So this is the one for ADDS, and this is the one for DNS. So I'm just clicking next through these. And I'm just going to click install. Now this can take some time to install. There is going to be something that we have to do before we can reboot the server and log into it as a domain controller for the first time. Namely, promoting this server to a domain controller, and it'll actually show you on the screen. Click here to promote the server to a domain controller. So I'll pause the video, wait for this to complete, and we'll resume when we see that notification, promote the server to a domain controller. Okay, so this just finished. So as I mentioned, we are getting a notification to promote the server to a domain controller. So I'm going to go ahead and click that. And now we're going to go through another wizard. So this is where we're going to specify, okay, are you adding a completely new forest, which we are. So this is actually the correct option here. Because if you look at the other options, add a domain controller to an existing domain, the domain doesn't exist yet. So this is not correct for our particular scenario. Add a domain to an existing forest. A forest doesn't exist yet, so that's not correct. So add a new forest. And this is where you can get creative with your name. I'm going to actually name this Lombardi.local, since Lombardi is my last name. For domain name, we're going to click next. This next screen is where you set your forest and domain functional levels, and this is sort of dictated based on what's your oldest server in the environment. So if you have a 2016 server in your environment, then you have to set those respective levels accordingly. So in this particular case, we're only going to have 2025, so I'm going to leave it as 2025 for both forest and domain functional levels. I'm going to leave so this is a DNS server, no surprises there, and it's also a global catalog. We're going to check or leave checked. I'm going to specify a password for the directory services restore mode. So this is used in case Active Directory needs to be restored. I'm going to click next. This is not selectable, so we're just going to skip through this screen. It's going to generate a NetBIOS name, so in this case it's Lombardi. So this basically tells you you can log in as like Lombardi/administrator or whatever account that's going to be created in Active Directory users and computers. So we'll click next here. We're going to keep this pretty simple. So I don't have a second volume attached as a data volume, but if you did, you could specify that here. So this is your database folder, log files folder, and sysvol. So we're going to just accept the defaults. Click next. And this is just a review. Now, one cool thing about this is you can actually click this button, View Script, and this basically shows you everything that was just done. So even the window that we're looking at has automation in mind, and this is using PowerShell. So if for whatever reason you want to automate through PowerShell or through Ansible, setting up a domain controller with a new domain and a new forest, you can. And this PowerShell script can be used, or Ansible can be used. So I'm going to actually save this as an aside, just to, if we ever wanted to automate that. I'm going to cancel out of here, and then I'm going to click next. It's going to go through a prereq check. And there is going to be a warning about the delegation of this DNS server. You can ignore that. But for all intents and purposes, the prereq check is completed and it's passed. So we can go ahead and click install. And I'm going to let this run, and we'll let the progress complete, and we'll come back when it's time to reboot. Okay, this has just completed, and we're about to be signed out. So we're going to click close, close, and it's restarting. So the next time we log in, we'll be logging in for the first time as the domain administrator. Okay, so we've lost connectivity to RDP. And one thing that we can use is we can kind of keep an eye on what this instance is doing. So again, how did I get here? You go to the instances, and if you click on, you right click the instance and you go to monitor and troubleshoot, get instance snapshot. We can pay attention or kind of see what is happening behind the scenes. So I'm not gonna try to RDP into this until I see a Control-Delete screen. So I keep refreshing your screen until you see a Control-Delete screen. Don't try to RDP into it until it's ready, because you're just gonna error out. So I'm gonna pause the video until I see a Control-Delete screen. Okay, so let's take a look at how we're doing here. Through this screenshot, you can see it's applying computer settings. We refresh the screen. Yep, we are ready. So now we can attempt to RDP. So we're still on the Bastion host here. We're gonna RDP into the private IP of the new domain controller. Connect. And as part of the promotion of the domain controller, the local account actually gets migrated to the domain account. So we can paste in the same password, and we will click yes and sign in. So one thing that you'll notice is if we right click on start and we go to system, you'll notice that domain or workgroup, if we click on that, you'll now see the domain is lombardi.local. Okay, and then this is the full computer name is now also lombardi.local. So this is set up. We have a functioning 2025 Windows domain controller, and the next thing to do will be to set up a test dummy server. But before we do that, we can also show, hey, Active Directory users and computers is available here too. So this should pop up and you'll see, yep, Lombardi.local is the name of the domain, and we have the default list of OUs here. So we're ready to rock. Let's spin up another 2025 server that will be the dummy server to domain join through Ansible. So this is the third time that we've went through this process of launching an instance for server 2025. So I'm going to try to make this section as quick as possible. So I'm in the Bastion host, and I'm in the AWS console. We're going to go to launch instances. And we are going to name this Win 2025 test 1. It'll be Windows Server 2025. We'll do another T3 micro, or medium, rather. We'll use the private key. Private. Change the network settings to my VPC. And the subnet will be the private subnet. We're going to select the existing security group. And we're going to select private SG. And 30 gigs is fine, and we'll click Launch Instance. Go to the instance. Now, the security group that's applied to this already has a rule inbound that allows RDP from the Bastion. So we don't need to make any changes to the security group roles. But we will need to wait for this to initialize. We'll keep an eye on it by going to Monitor and Troubleshoot, get instance screenshot, and we'll wait for the instance to get to the Control-Alt-Delete screen. And it is. So we're going to have to get Windows password again. So let's do that. Security, get Windows password. We just have to wait a little bit longer. We're going to upload the PEM file, AWS private, decrypt the password, and we're going to copy this password to our notepad. Okay. So now let's grab the private IP of this server, and we will RDP into it. Gonna RDP into it. We'll specify administrator as the username, and we'll paste the password in. That's not quite long enough. That's not the right one. Click OK. Click yes, and should get right in. And the only thing that we're going to really do on this server is change the time zone and change the computer name. We're going to leave it as in a work group because we're going to allow Ansible to domain join for us. Go to the search bar and type in time. And set the time to Eastern Standard, or Eastern Time. Okay. So you can see it's a late night for me. It's almost 2:30 a.m. And we'll just change the computer name. Right click on Start, go to System. and rename this PC. And we're gonna name it what we named it over here. So that would be actually, I'm going to intentionally name it Win 2025 test without the 1, just because I want to show you when Ansible, one of the steps in the playbook that we're going to have is to rename the actual computer. So we will name it to test 1 at that point. So for now, we're going to just name it as Win 2025 test without the 1. Click next. Restart now. We'll lose the RDP connection, and the next time we sign in, the computer name will change. And we'll verify that in just a moment. Take a look and see what the machine is actually doing by getting the instant snap screenshot. And once we hit the Control-Alt-Delete screen, we will RDP again. Okay, it's ready. And we're going to enter the password in one more time. There is a delay here, as you can see. Hasn't reflected here yet, but it will. So let's right click on Start. Let's go to System. Oh, and you can see it did change. And if we go here, it also changed here. If we go to Domain or Workgroup, we'll see that this is still in a workgroup by design. So the test dummy Windows 2025 server is all set, and we're ready. We're going to take a little bit of time away from the Windows side of things, and we're going to return to Ansible. So I'm going to sign out of here. And the next section will cover some additional setup required for Ansible, mainly to make sure that Ansible can talk to Windows. So now that we've set up the Windows servers, the DC and the dummy server 2025 machine, let's head back into Ansible land. So this is going to be a 5-step process. We're first going to create a security group role so that Ansible can communicate on the secure WinRM port to the Windows dummy server. Then we're going to create an access key for programmatic access, and we're going to configure AWS credentials on the Ansible server. The third thing we're going to do is we're going to prepare the Windows dummy server through a PowerShell script. So we'll walk through that. Fourth, we're going to create the inventory file for Ansible, and we're going to walk through how to create that. Then last, we are going to test connectivity from Ansible to the Windows server using the WinPing command. And we'll show you how to do that as well. So let's get started. Okay, so we need a security group role inbound in our private SG to allow WinRM secure from the Ansible server. As mentioned before, the primary connectivity method for Ansible to Windows is WinRM. As an aside, SSH is in beta for Windows connectivity, but it could be taken away at any time. So really, you want to use WinRM. And we're going to be using the secure version. There is an insecure version of WinRM. We're going to be opting not to use that version. So all we have to do here is we need to go to our security groups. We go to the private SG, and we're going to edit the inbound roles, and we're going to add a role. And luckily enough for us, there actually is a built-in WinRM port, so WinRM HTTPS. That's what we care about. That's the secure version. And that's on port 5986. And the source, it's coming from Ansible. Ansible is making that call to the Windows server. So let's open up EC2 in a separate tab. And we're going to grab the private IP of the Ansible server and put it as the source. So let's do that. So Ansible, private IP address, we're going to copy that. I'm going to go back to our security group rules, and we're going to paste in the private IP /32. And we're going to, as the description will say, allow WinRM secure from Ansible. Save roles. And that's it. The second thing that I'm going to do is I'm going to create an AWS access key. This access key will be stored on the server in this particular video. There will be a part 2 of this video that will automate everything that you're seeing. But for this particular video, we're going to generate the key and store it on the Ansible server. In the second video, it'll be passed as a secret into a pipeline. But for this case, we're going to create the key and store it on the server. So I'm back in AWS, and this time I'm actually not in my Bastion host, and there's a reason for that. The Bastion host doesn't have Excel installed, and we're going to be able to have access. When we generate the access key, it's going to come in the form of a CSV file, and I have Excel on my laptop, so I'm actually logged in. This is my Bastion, but this is I'm doing this on my laptop. So what we're going to do is we're in the AWS console, okay, and I'm going to actually type in IAM. I'm going to go to the user section, and I'm going to go to my user named Joseph that I created. You can create a user up here if you need to. Then I'm going to go to the Security Credentials tab, and we are going to create an access key. So create access key. Can select the option, this is for CLI. I understand the recommendations. Click Next. And we don't need to set a description tag, but I will. I'm just going to call this Joseph Access Key. Actually, we'll date it. Joseph Access Key 011925. Create access key. Okay, so you're only going to be able to see the screen once, but you can download it as a CSV file, so that's why I'm doing it on my host. So I'm going to download the CSV file. There it goes. Okay. And I don't care if you see this. I'm going to delete this access key by the time the video is uploaded, so I don't mind if you see the access key in the secret. So this is going to open up Excel, and you're going to see it's going to be in a CSV format, and that's my security, my secret access key, and my access key ID. So what do we do with this now that we have these access keys? We're going to store it on the Ansible server. So now I need to go back to my Bastion host. And one thing that you can do is in Google, if you do AWS credentials file, it's the first thing that comes up. We're going to go here. And if we scroll down, since these are short-term credentials, this is the format we're looking for. Okay, so if we look at the access key ID and the secret access key, you're going to see that that matches with access key ID, secret access key. That's what we need to store on the Ansible server, so it knows what AWS account to use. And we don't need the session token. Typically, session token is used like if you've got a rotating set of credentials. Setting up rotating credentials is outside the scope of this demonstration. So that's what we're looking for. So what we're going to do is we are going to we're going to actually SSH into the Ansible server. So let's open up a command prompt. We're going to change to our downloads directory, because that's where, if we list the downloads, we'll see we have AWS private key, and that's what we need for the PIM file. So one little cheat sheet here for connecting to SSH is if you select the Ansible server, you click connect and you click SSH client. We're just gonna copy the example because that's exactly what we need. So we're going to paste that in, and we are once again in our Ansible server. So what we need to do here is we need to make a directory called .aws, and we're going to change into that directory, and we're going to make a file called config. So we're going to touch config, and then we're going to use the VI editor into config. Okay, we're currently in command mode in the VI editor. We're going to press I to enter insert mode, and we are going to reference this. So all we need right now is this part. We're going to paste that in here, and we're going to reference our file here for the secret key, the access key ID. I'm going to copy that. I'm going to go back to our Bastion host and paste it in, and then secret access key we need. I'm going to paste that, and we're going to copy and we're going to paste that into our file here, and that's it. That's all we need. So we're going to save this file by pressing the escape key to go back into command mode. We're going to hit :WQ exclamation point to save the file, and we're going to press enter to save. And that's it. Now we will run a PowerShell script on the Windows test server so that the HTTPS listener will be ready to communicate with Ansible. So let's do that right now. So right now I am connected to my Bastion host. So we're going to RDP into the test instance, and that's the instance that will be domain joined through Ansible. So we're going to open up RDP, and we're going to grab the private IP of the test server. So let's copy this over here, private IP, and we're going to just paste that in here. And we're going to connect using the password. We are connected to the test server over here. Okay, so on the test server, on the desktop, we're going to create a new file. Do new text document. And we'll call this prepare Ansible win. We're going to go into that file, and we're going to go to View, Show, File Name Extensions, and we're going to change the extension to a PS1 for PowerShell. You're going to get a rename. Are you sure you want to change it? Click Yes. You'll see the icon changed. And we're going to edit this with Notepad. Okay. So now, let's minimize the screen, and we're going to open up Google, and we're going to type in Windows Remote Management Ansible. Okay, and it's the very first page here that shows up. We'll just make sure this is the correct one. Yes, this is the right one. So just as a caveat, a couple weeks ago, I noticed this page didn't have any of these PowerShell related statements here. So what I ended up having to do is kind of get in through the back way to go to the GitHub repository directly to get access to this. So that's just a caveat. If you don't see enable PS remoting and all these PowerShell related commands here, you may have to get in through the back way, and I'll show you how to do that real quick. So if you come up here and you see edit on GitHub, what we're going to do is we're going to right click this, and we're going to copy the link, and in Notepad I'm going to paste the link here. And what you're going to do is you're going to just capture this first part here and go to copy, and we'll paste it in here. So this will go right to the directly to the GitHub page. And the path that we're looking for, we can ignore some of this, but it's going to be docs, docsite, RST, OS guide. So docs, docsite, RST, and OS guide. Okay. And then Windows, WinRM, RST. That's the file that we're looking for, and all this other stuff is not important. So Windows _ WinRM.rst. Okay, and this is the GitHub equivalent of what you see here. Okay, so, and you'll see, okay, you've got the PowerShell related commands here that we need to run. There was a discrepancy between this site and the GitHub. So if you don't see at the time of if you were to try this out and you don't see these specific commands, just know there's a way to get there through GitHub. So, okay, now that we have that in play, we're going to actually copy this website. Let's see if we can access it through this test instance. We should be able to, because of the NAT gateway. Let's just make sure we have internet access. We do. due to the NAT gateway. So let's paste that link in just to make it easier. Okay, and then what we're going to do is we're going to put this side by side next to our text document. Okay, and yeah, let's put that over to the left. So let's scroll down. You can skip all the stuff regarding pipx and pip3. So the very first thing that we're going to copy over is this line right here. Copy that over. Enter some spaces. We are not using the insecure version of WinRM, so you can completely skip this step. And what this step does is it basically opens up the Windows firewall to allow inbound the insecure port. So let's skip this. But we'll add this just because we are using the local administrator account initially. So this allows a local user, the administrator, the local administrator, to be able to use WinRM. So we do want to include this. So we'll copy and paste that over. And then all of this is relevant. The HTTPS version of WinRM does require a certificate. You can make your own. That is outside the scope of this demo. We're going to just use a self-signed certificate. This next block right here, it creates the HTTPS listener on the Windows host. So we're going to include that. And then the next block underneath here creates a inbound rule for 5986. So we're going to also include that. So all of this, we're going to just click copy, right? And then we're going to hit paste. And then last but not least, we are going to actually include this line to enumerate the listeners. And you're going to get an output like this. So we're going to include this as well. And that'll be the last section of this, this PowerShell script. So now that that's done, we're going to close out. And we're going to save this PowerShell script. And we're going to run it. And what we want to see is the HTTPS listener is listening, and then this Windows host will be ready. This is something that will need to be run across any Windows machine that you plan to manage with Ansible. Okay, so let's open up PowerShell. Okay, and we're going to change to the desktop. And to run a PowerShell script, you're going to just do a period, a slash that's above the enter key, and start typing prepare, and then you can use tab completion. And then we'll press enter. And so the final output that we're looking for is that HTTPS WinRM is listening. So we just need to verify that, and this section of the demo will be complete. So this, okay. So it actually did include output for the HTTP, even though we didn't include it. But we're mainly concerned with this port. That's what we really care about. So this section is done. So now we're going to create an inventory file, and we're going to walk through that. Okay. So now we're going to open up Visual Studio Code. Okay. And I would create a folder at the root of your username. I've already created one in advance, so where I'm going to open up that folder. And you can see my name, Joseph Lombardi. And I created a folder called Ansible Demo 2024. So we're going to select this folder. And we're going to create a file called inventory.yaml. Okay. Now, documentation is super, super helpful in this regard. So you're like, what's an inventory file? You'll kind of understand this as we go along with it, but if we look here, there is a document on Ansible, Ansible official documentation for how to build your inventory. Okay, basically you're telling Ansible how you want to connect, what you're connecting to, and how you want to connect, by what method. So in our case, it's WinRM, so you specify WinRM in the port. So you can find this by going to google.com, how to build your inventory. So we'll just proof of concept here. How to build your inventory Ansible. And it just shows right up. And this is the document that we need to look at. So when we are creating our inventory, you have two options. You can create it in an INI file, or you can create it in a YAML file. Now, I highly suggest opting for the YAML version, and the reason for that is because you're going to have usernames and passwords in this inventory file. And you don't, if you're pushing this to a Git repository, you don't want that to be in plain text. And the Ansible vault that helps safeguard your username and password or any sort of sensitive information is not compatible with this INI version. It's only compatible with the YAML format. So err on the side of using the YAML format just from a security perspective so that you can call your secrets file later and then just specify your username and password as variables, and then you can push that to your repository, no problem. Your passwords and your usernames are not in plain text that way. So this is generally how this works. So anything you see in INI, we're going to be using the YAML version. So you have a name of a group, you have the hosts, and then the hosts basically are, in our case, it would be the internal DNS of our Windows 2025 server. And it ends with a colon. So we're going to do that, actually. So let's do that right now. So we're going to actually copy this over. We're going to modify it just a little bit. So let's go over to Visual Studio Code. We're going to paste what we just copied. And we're not doing a web server, so we're going to actually name this group Win for Windows. And all we need here is the internal DNS of the dummy server, dummy 2025 server. So let's go and open up our EC2 console. Let's go to our instance, and let's snag the DNS name for our test server. So we'll do that right here. We'll go back to Visual Studio Code. And rather than this example, we're going to just replace that. We'll keep the spacing the same. And there's that. Okay. Something we also need to factor in is variables. You know, how are we connecting to this particular host? By what protocol? By what method? WinRM. So now we configure that next by specifying variables. So we're going to do that right now. And actually, the document right here, shows you that too. Like if you scroll down far enough, it'll show you. So we're back on the how to build your inventory page. So if we go down here, like all the way towards the bottom, you'll see that there's variables that you can specify. So how we did it with win and then the host, you'll see that over here. Okay, so the name, the group name rather than Atlanta is win, right? And then you got the hosts, and we already specify the hosts. just the internal DNS, and then vars goes underneath it. So what do we need for vars? Well, this is actually where the remote management page does come in handy. Okay, so there is a Ansible document called Windows Remote Management. Okay, so if you were to go to Google and you were to type in Windows Remote Management, Ansible, it's the first thing that shows up. And if you scroll down, it's going to show you, here are some basic variables that we need to add. So we are actually using, we're going to use NTLM for this example. So all we're going to do, and you can already see the problem here, username and password. We don't want that in plain text. So we're gonna put it in plain text just for this demo. There's gonna be a separate section on how to integrate this with Ansible Vault, and it is gonna be in this video, so stay tuned for that. So we're gonna just copy this, okay? And we're gonna paste it in. Make sure the spacing's right. So not too bad so far, right? There's a few other things that we do need. So right below it, interestingly enough, there's the port. So we want to also include the port. We want to specify, we are using WinRM and we're using NTLM as the transport method, but we also want to specify, hey, we're using the secure port for Ansible. So that's something else that we want to include. So let's open up, we'll put that right underneath. See, that's the insecure port. We're using the secure port. And then I believe there's only two others that we need here. So with that, let me just verify that real quick. So we have the Ansible user, the password, the connection, and the Win transport. So we copied and pasted that from up here. Yeah, it's from here. And then we borrowed the port down here. And there's actually three more that we need. Okay. So one thing that we need to factor in as well is we need to tell this that, hey, we're using HTTPS. So towards the bottom here, you'll notice at the very bottom of this document, Windows Remote Management, you'll see some extra parameters here. So a few that we need is the scheme. So we're going to borrow this, and we're going to open up, go back to Visual Studio Code again. I'm going to put this here, and we're going to specify HTTPS. Okay, HTTP or HTTPS. Then there's two more that we need. Okay, we need the cert validation. We want to ignore it because we created a self-signed cert. So cert validation, we want to set this to ignore, because by default it will try to validate the certificate. So we want to specify ignore. So we're going to go back here, put this here, set this to true, or ignore rather, I'm sorry. And then final one is the WinRM Kerberos delegation. I'm not sure you really need this one. Except for you do WinRM Kerberos delegation, bypass the double hop issue, and access network resources. So this is a known limitation. So we're going to actually put that here. This is in the same document. So we're going to open this up, and this will be the last one we set. And of course, we want that set as a colon rather than a equal sign. So that is the inventory file. So it's a little bit of Frankensteining of referencing this document right here for Windows Remote Management, but it's through trial and tribulation that I got this to work. So this is what you need. So if we open this up, now we want to copy this over to the Ansible server. So all we need to do is do a Control-All and copy, Control-C. We want to go back to the Ansible server. We're going to go back a level, do a present working directory. We're at our home. Okay. And we're going to touch a file called inventory.yaml. And we're going to VI into that particular file. We're going to enter insert mode, and we're going to paste. And that's exactly what we just worked on in Visual Studio Code. So now you can already see what the problem is here. I have to enter the username, which is administrator, and I have to specify the password in plain text. So we will fix that once this is connected. We will create a secret, and then we'll make this a variable. But for now, just proof of concept, I am going to enter it into plain text. This is just part of a demo, but Ansible Vault is included in this this demo video. So for now, there's a password. Okay, we'll save that. We'll quit. Everything else looks great. And our inventory file is done. So now, the final step of this, to prove that this all works, right, is to test. Can we communicate with the server, right, this Windows server from Ansible? So we're going to test that right now. So what we need to do is we're going to clear the screen. We're going to do Ansible. We're going to specify the inventory file. And we're going to specify the group name, which is Win. And then we're going to specify the module as WinPing. And let's try it. We have a success. So all those 5 steps, basically this proves that Ansible is talking to that Windows server. Okay. Now that we have that configured, we can start working on the Ansible Playbook to do the domain join. And that'll be in the next section. Okay, so now it's finally time to write the Ansible Playbook, and the Playbook is the magic behind doing the domain join for the Windows server using Ansible. So the very first thing that we want to look at is, what is a playbook? What's the general format? Okay, how do you write one? So with this, basically every playbook starts with these 3 lines to sort of denote that it's a playbook. Okay, and then you have underneath it, you have the name of the play, the host that it's impacting. So in our particular case, it's going to be Win, because we have that specified as the host, the name of the group. And then you have the list of tasks. What are you trying to accomplish? So we have to sort of reverse engineer the process of what's involved in joining a server to a domain. Okay. So let's start. So we're going to open up Visual Studio Code here, and we're going to actually create a new file called domain join.yaml. And we are going to start our play with 3 hyphens. Okay. And then after that, we're going to name the play. What are we doing exactly? We are domain joining the Windows 2025 server. That's what we're doing. What does this apply to? Well, the hosts file is Win. It's the Win group that we created here in the inventory file. Okay, so this is what it's referencing. Okay, and then after that, now we can specify the tasks. And under the tasks, we have a name for each task. So what we're doing exactly. Okay. So now that we have that in play, what is the first thing that we do generally when we're talking about servers just set up from scratch? Chances are we're going to change the host name. Okay, number 1. Number 2, we're going to reboot the server after the host name is changed. Then 3, we're going to configure the DNS settings so that they point to the DC, assuming that the DC and the DNS server are the same, and in this case they are. So we want to have a step for that. Then we want a step where we're appending DNS suffixes so that lombardi.local shows in the network list of suffixes. And then finally we join the Windows host to the lombardi.local domain. Okay? So that's kind of a breakdown. So if we look at that here, let's show that from a GUI perspective. So as we mentioned, if we look at the server here, let's say we want to, if we were to manually go through the GUI, we'd look at the system, all right, and if we wanted to rename the PC, we'd have to click this button to rename. So maybe we'll do Win 2025 Test 1 instead of Test. In fact, I think that's what it's named in AWS, so it should be Test 1, so we should do that as a rename. So that's the first step. Then we'll want to reboot. Then we'll want to go to Network Settings and change the Ethernet setting so that it's, DHCP is fine, but we want to statically set the DNS. So we would edit the DNS assignment so that it's manual, and we would specify the DNS server here. And then after that's done, there's another setting to change the DNS suffix. So we would want to do that as well. So if we go to DNS settings, it's not present here, but there's a way to do it through PowerShell to change the suffix order. So then once we do that, and it has lombardi.local rather than ec2.internal, we don't want that as the primary suffix. Once we do that, then we join it to the domain, because it'll be able to talk to the DNS server that the DC is attached to, reboot, and then you'll be joined to the domain. So that's basically manually how to do it through the GUI, but we want to reflect that in the playbook. So first step is renaming the server to match what's actually in AWS. So we're going to do test 1. Okay, so let's do that now. So a couple things to bear in mind here, now that we know what the playbook kind of generally looks like. We want to look up Ansible Windows, and over here we want to look up Ansible Active Directory. Those are the 2 modules that we installed. Okay, So we want to click on the main page here. So the first thing we want to do is rename the host name. So what we're going to do is we're going to look at the modules that are within the Ansible Windows collection, and we're going to look for hostname. And the great thing about this documentation is at the very end of each module, you have examples. So this is exactly what we want to do. We want to change the host name, and then we want to reboot. So that covers that right there. So what we're going to do is we're going to actually copy this, and then we're going to paste this into our tasks. Okay. So we're going to just paste this here. Gotta make sure that the spacing's correct too. Okay. So we're gonna change the host name to, what did we have this server as? Win25-test. Let's say Win25-test1. And that's gonna be the same value as the name over here. Okay. Then we're gonna reboot. So this just registers that a reboot is required. So changing the host name, and then doing a reboot. Okay? That's step one. So we've changed the host name, we've rebooted, now we want to configure static DNS settings. So let's create another task called configure static DNS servers. And now we're going to reference the documentation here. Let's go back to the main Windows collection. And now we want to look for something called DNS client. Okay, so let's go to DNS client, and let's scroll down for an example usage. And this actually looks great. We don't need a log path, but this looks great. We can actually copy this. So we're going to copy this and then modify it to our needs. Sorry, wrong window. So we're going to go over here, and we're going to put this here. And for whatever reason, the spacing is not quite right. This actually is a subset of here, and this is on the same level, and then this is underneath the DNS servers, and we don't need the log path. We can erase that. And actually, it's just one DNS server. It's the 10. This is the DC, so 10.0.0.28. This applies to all Ethernet adapters. And we are going to just rename this to something that makes more sense for us. So configure static DNS server. That's already the name, so this is actually a duplicate. Get rid of that. So this is applying to all adapters. So Ethernet 1, Ethernet 2. We're specifying the DNS server. And now what a good idea to do is to, we mentioned applying the lombardi.local as the DNS suffix. Because if you look here now, if we look at the DNS suffix, right, under network connections and under Ethernet, right now the primary DNS suffix is ec2.internal. We don't want that. We want lombardi.local as the primary. So this is one of those cases where you do, built-in modules don't seem to be able to provide that functionality, and you do have to rely on PowerShell. So if we look back here, I actually kind of did this in advance. So there is a PowerShell command, set DNS client global settings. And this actually, like if we look at the example here, this is exactly what we want. So you're gonna have ec2.internal as the list here, but also what's not shown is US East 1. That's another one of the suffixes, but we want lombardi.local to be the very first one. So we're going to actually we're going to go back to the Windows, module, and we're going to actually look at the PowerShell module within. So this is the Windows collection. We're going to go to PowerShell, and this is how you use it. So if we scroll down, it gives you an example of how to use a script. So we're going to copy this, and this is the PowerShell that we're going to add at the end of this line. So let's copy this example. Let's go over to this file here. This is our playbook. Okay, we have to format this one more time. And script is actually underneath here. And this is the script right here. Okay, and we want to grab this set DNS. I'm going to copy this to set the DNS suffix. So we're going to go back here. Rather than echo, we're going to specify this set DNS DNS client global setting, and it's actually not going to be Contoso, but it's going to be lombardi.local. And just from my own experience with using this particular command, we are going to, there's a couple others that we need. So I'm going to remove this. So we saw that ec2.internal was one of them, right? So if we go over here, we actually see that right here. But there is another one, and I'm going to add that as well. And that was more visible on older versions of Windows. I'm not sure if there's a way to get to network connections, the old menu. View network connections. Okay, you can view network connections. Yeah. So here's the old school way of looking at the NIC. So if we look here and we go to properties, and then we go to TCP/IP version 4, and we go to advanced and then DNS, you'll see this one also is there. So what we're looking to do is have lombardi.local be the first one, then these two can come next. So this is what we're looking for. I don't think I can copy that, so I have copied that in advance. So let's minimize that. And right here we're going to put US East 1.ec2-utilities.amazonaws.com. And we'll put a quote there and then a comma. EC2 internal. And that looks good to me. So you're capturing the domain name here, the suffix. Then US East 1 ec2-utilities.amazonaws.com, and then EC2 internal. So that captures that. And then last but not least, the fun part, joining the domain. So up until this point, you'll notice that we've only used Windows, the Windows module. You know, we've used DNS client, we've used reboot, we've used hostname, we've used PowerShell. Now we do need, we can get rid of some of this stuff over here. We do need the Active Directory module. So if we go to Active Directory, you'll see that there is one called membership. And if we go to the AD membership module and we scroll down, there are examples here as well. So we want to join, we're going to actually copy this here. Okay, and we're going to include a reboot as well. So we're going to copy this, and we're going to add it to our play. Okay, we actually want to indent this. That looks good. So we're not running a basic PowerShell script. What we're doing is we're appending these DNS suffixes in order. And then here we are, the name of this particular task is join Windows host to lombardi.local domain. Okay, and here we need the domain name. So it's going to be lombardi.local. And the host name is going to be the same as up here. Okay. Then the admin user is going to be, we're going to actually specify, so we know it's going to be lombardi.local, but we'll say that it's actually administrator. The password, we'll put the password here, and then the OU path, we'll make it complicated just so that you can see we'll actually specify an OU path just so we can see that it can handle underscores and difficult characters, then domain and true. So just a couple things to tie this up, and then this play's actually ready to go. So one thing that we want to do is let's create an OU that's kind of complicated. Okay. So let's go to our domain controller, get rid of all this stuff. Okay. And we're going to actually sign out of this. And then we're going to open up Active Directory, users and computers. And let's say we have a complicated setup, like multi-path. So let's say we're going to do a new OU. And we're going to say vendors. Okay. And then underneath vendors, maybe we'll do new OU. Let's do something interesting. Let's do like 1.IT and then we'll do like another sub OU just to make it even more complicated that begins with an underscore. Let's say tech MSP, something like that. I used to work on MSPs before I was doing DevOps, so and then we'll add some, you know, commas. Tech MSP, Connecticut. So we purposely added a comma here to make this more complicated. So we're trying to trip Ansible up. It's Massachusetts. Okay. So we want the computer to be joined in this OU. Okay. So the way that we're going to do this is, if we go to properties, It's not going to tell you much in terms of what is the OU of what is the OU path of a given OU, right? Like, how do you find that information? So, I mean, even if you look at, if you view advanced features, right? And we look at vendors, and we go to properties, there is an attribute editor where, ooh, we got the distinguished name. But that's what we're looking for down here, like this hierarchy. So if we right click, so I just turned on advanced features, I right click and I go to properties, and then I go to the attribute editor. This is the distinguished name. This is what we're looking for. That's what the OU path is. So when we look at this right here, this is what we're trying to define. So that's really the missing key piece here, and then plus the password. So if I go back to this particular OU path, okay, I wonder if it's going to let me copy it. That would be great if it did. We're going to actually use single quotes instead of the double quotes, just because it trips up any of the special characters. Maybe it'll let me copy or paste. That would be great. Fantastic. Okay, so that kind of takes out the guesswork in terms of like what the distinguished name is, but this should work. So you see there's, why is there a slash here? It's just because whenever there's a comma like this, you need a slash. Okay, so that's something to bear in mind when we're looking at this. There are commas here, so you need, slash comma, slash comma. That's just the notation. That's something to trip you up. But in terms of like the dot itself, like you see there's a 1.it, that doesn't matter. You can, and as you can see from this name here, it handles the dot just fine. Okay, so this should work. So then the only other thing that we need here is the actual password. So the password, again, I'm going to put this in plain text for now. We are going to use Ansible Vault to protect this, but I just want to show you that the domain join actually works. Okay, so let us do, let me grab the password. There it is. Okay. And as you can see already, that's a problem. Like, so not only in the inventory do we have an Ansible user and password, right? But we have one also over here for the administrator for that particular user, and then the password itself. And so you want to safeguard that. So we'll cover the secrets momentarily. So now we're ready. Let's copy this over to the Ansible server. So I'm already logged into Ansible, and as you can see from the last section, we just have the inventory. So we're actually going to create a file called domainjoin.yaml, and we're going to VI into that. And we're going to enter insert mode, and we're going to paste what we just did. This is the play. Okay, so let's escape to enter command mode, :WQ, exclamation point to save. One more thing before we attempt to run this playbook. We are missing some ports regarding AD join, so we need to add those. If we look at our private security group, so far we have just 3. We have one for SSH, one for RDP, and one for WinRM secure. So we need to add some inbound ports from the domain controller's private IP to facilitate or allow the domain join process to happen. Otherwise, it's going to error out and say that the domain controllers can't be reached. So let's do that. So let's open up Google. And we're going to actually just reference the Windows documentation for this. Windows domain join ports. Okay, and we'll go to the configure firewall for AD domain and trusts. And if we scroll down here, we want server 2008 and later versions. These are all the inbound roles that we're going to need. We're going to attempt to not... worst case scenario, we can add all ports for the given private subnet because it is a trusted subnet, but I really want to try to get this to work. I've tried to record this previously and it didn't work, so thinking now that we're just dealing with one subnet, all the servers are on a private subnet, hopefully that'll rectify that. But worst case scenario, if we have to allow any on just the private subnet, we will, just to demonstrate, hey, a domain join can happen. You could also look at VPC flow logs. That'll tell you source and destination and port if it's allowed or rejected. But let's try to do this first. Okay, so what we're going to do is on the right-hand side, we're going to pop this over to the right. And we're going on the left, we're going to have the private security group. Okay, and before we do anything else, we do want to capture the IP for the domain controller. So let's grab that first. So that's right here. We're going to copy that. It's the domain controller. And we're going to go back to security groups, and we're going to go into the private security group. And we're going to add inbound roles. Let's change the zoom level so that we can see what we're doing. That's much better. So every one of these, this source or where it's coming from is going to be the DC. So we need to add all these ports. Now, one thing to note is that there's some duplicates here. So you'll see 49,152 to 65,355. That repeats 3 different times. So that's just something to be aware of. So let's add them. Add rule. First one is going to be the time service. So we're going to select custom UDP. We're going to specify 123 as the port. And the source is going to be the DC. And we're going to say that for the description, allow W32 time from DC. We're going to add another rule. This time it's TCP. We'll specify port 135. Also put in the domain controller. Allow RPC endpoint mapper from DC. Add another rule. This time we need TCP and UDP for port 464. So we'll do TCP first. 464. Paste in the DC private IP. Allow Kerberos password change from DC. Do the same with UDP. Same port. Same IP. Allow Kerberos password change from DC. Okay. And this is TCP, so we're going to copy this. And again, this appears 3 times. Once, twice, 3 times. So we'll specify the port range here. We'll copy over the DC. We're going to just say allow custom range from DC. Add another rule, UDP and TCP for LDAP. If we specify just LDAP, it's going to be the TCP version. So LDAP, TCP 389, paste in the IP, allow LDAP TCP from DC, and we'll do a custom UDP with the same port 389, same IP, allow LDAP UDP from DC. Okay, we're almost done. This is the secure version of LDAP. So TCP 636. Paste that in, allow LDAP secure from DC. Just a few more. These two are actually a range, so we can actually just use one rule for both of these. So this is TCP for both, TCP 3268 to 3269. Specify the DC, allow GC from DC, global catalog. So DNS, UDP, and TCP, there's actually a rule for that. So if we type in DNS, UDP, TCP, so we'll do UDP first from the DC, allow DNS, UDP from DC, and then DNS will do the TCP version of that, paste in the DC, allow DNS TCP from DC. Okay, that covers that. We already got that port range. So there's just three more. There's the TCP and UDP version for port 88, and then for 445, which is SMB and also NTLM. So let's cover that. Add a rule, custom TCP, 445, put in the DC IP, and that's allow Kerberos TCP. Oh, I'm sorry, that's port 88. Skipping ahead here. So 88 TCP, allow Kerberos TCP from DC. Two more. Custom UDP, port 88, paste in the IP, allow Kerberos UDP from DC. And final one, TCP, I'm just going to put in SMB, which is 445, that's already a preset rule, paste in the IP, allow SMB from DC. And we're going to save those rules. So quite a few. I just kind of did a speed round with that. Okay, so now that we have those inbound rules set to allow LDAP and domain joining, let us try to run the playbook and see if we get any errors. Worst case scenario, we can allow all ports from the private subnet. I prefer not to do that, but I know that that will work. So that's a worst case scenario. Okay, so we're in our Bastion, and we're connected to our Ansible server. So to run the play, the command is Ansible Playbook specify the inventory. We also have to specify the name of the play, so domain join inventory. That should do it. But I'd like to connect to the remote desktop session so you can see in real time the changes that are made. So let's just confirm that 17 is in fact the test server. It is 17, so let's go back. Let's RDP into that. And we're going to paste in the password. Test. And in real time, you'll be able to see the hostname change, and then it'll reboot. We'll be able to see that in real time. So let us go over to Start, right-click Start, and click System. And we're going to pay attention to the domain or workgroup. We'll see if this screen changes. So we're going to actually minimize this. And we want to just see if the host name changes. We should see it reboot too when we run the play. Okay. There it is. So now, let us run this playbook. And we cross our fingers and hope that we get lucky and that no errors happen. There we go. So there it is. It's gathering the facts. It's going to find the IP that we specified from the host section, and it found it. And now it's going to change the host name. So it just changed it. And now it's going to reboot. Oh, just rebooted. I didn't do it. I swear. So you saw that in real time, that Ansible did that. That wasn't me. So now it's going to finish rebooting. And we'll just wait for that process to complete. And now it's configuring the static DNS server. So it's important to name your tasks accordingly so you know what's happening. So it's going to set the static DNS to the domain controller, and it just did that. And now it's going to append the DNS suffix. And now we're going to attempt the Windows host to join the host to the domain. And this is where it's errored out in previous tries of this video. So let's hope it works. Does not exist or cannot be contacted. So we're missing a port. And what we could do is we could set up VPC flow logs to find out what port's being rejected. But just to show you that it works, you know, VPC flow log troubleshooting isn't really in the scope of this video. So let's actually go, in the DC, you can see if we, this is the DC, if we refresh, it's supposed to appear here. So if we change the security group to allow all from the private subnet, it will work. I've seen it work. So let's go to VPC, open that in a new tab. Go to subnets, and we're gonna just allow the private subnet. So the private subnet is this. And just for troubleshooting and proof of concept, we're just going to go back to the security group for private. And we're going to edit the inbound rules, and we're going to allow all from that subnet. Because we're missing a port, which is a little frustrating because it's like you follow the Microsoft documentation to a T and you're still missing a port. So we're going to allow all traffic from this source, which is the entire subnet. So allow all traffic from private subnet. We'll save those rules. We'll go back to our Bastion, and we're going to rerun the play, and it should succeed. So all those ports we just made, I'm still missing one apparently. So let's rerun the play. Now it will say OK in green if it skips, like if it's a redundant task. This is something called item potency, which basically keeps you aware of state management. So it already knows that the host name is test1, and it already knows that the static DNS is green. The DNS will always change to orange because it's unless you add additional logic to handle, to check OK. So just be aware of that. And this should domain join because we allowed all traffic inbound. And let's actually check on that. Let's refresh the screen and let's see. Yep, there it is. So all those ports we added, we were still missing one because this is the computer. It domain joined. So really, VPC flow log troubleshooting is not really in the scope of this. We did try to keep this as secure as possible by only allowing all traffic from within the private subnet itself. Sort of proves that it is an SG related issue and there's a port that we missed. So as you can see, it changed. So the domain join was successful. Now, if we go back to this server, which is the test server, we're going to log into it for the first time as the administrator. So now we're going to have to use the credentials of the domain admin, which is actually going to be the DC password. So if we click this and we click OK, actually let's specify Lombardi/administrator and let's enter the password. And we're logging in to the domain for the first time on the test server. So definitely an inbound security group port role that, because I allowed all traffic in the private subnet and the domain join worked. When I do find out what port I'm missing, I will include that in part 2 of this video, but just this is a proof of concept from a manual perspective. The only thing that we've automated really in this video is the CloudFormation template for spinning up the VPC, and then Ansible was an automated event. So part 2 of this 2-part video series is going to cover the automation piece, and once I find out what port I'm missing, I will include that in that video. So if we right click on this computer and we go to system, we go to domain or workgroup, we can see it's a part of the domain. Okay, so the domain join was successful. This test server is joined to the Lombardi.local domain. As part of the steps from that playbook, we can see, we rename the PC to append a 1 at the end. If we also examine, and then we know that it rebooted because we saw that happen live. So that was part 2. And then part 3 was checking the network connection, so we can verify that. Changing the DNS server to be the DNS, to be the IP of the DC, which it was set here statically. So the Ansible playbook did that. And then also appending the DNS suffix lombardi.local was also done. And then finally, the domain join happened. Okay, so that's that. We're going to do 2 final parts of this video because of how long it is. We are pushing close to the 3-hour mark at this point. So we're going to cover how to use Ansible Vault to protect your passwords. And we're also going to cover parameterizing the Ansible playbook so that it can be used for any OU, any domain. So we're going to do that next. Okay, so we have sensitive data in both the domain join playbook and in the inventory file. So in the domain join playbook, we have the domain user and password. And in the inventory file, we have the Ansible user and password. How do we encrypt this so that we can safely upload this to a Git repository? Because right now we cannot. So it's a combination of two things. It's the use of creating a variables file and then encrypting that file using Ansible Vault. So the very first thing that we're going to do is we're going to create a new file called secrets.yaml. And in this file, we're going to add the 4 key value pairs that are holding the sensitive information. So in the case of the inventory file, we're going to just copy this entire thing and we're going to put it in the secrets. We're going to go back to the inventory and we're going to put the password in there as well. Okay. And the same holds true for the domain join. We have a domain admin user that we're going to copy over. We're going to add that to the secrets. And the same goes with the password. I'm going to copy that over and put that into the secrets. So username and password for both Ansible and the domain, that's secret information. So now that we've created this, we're going to pop this over to the Ansible server. So we're going to go back to our Ansible server, and we're going to vi secrets.yaml. And we're going to paste the contents of the sensitive information into this file. Okay? We're going to write and quit. And so if we cat this now, we're going to see everything. So not too secure right now, right? Now, to encrypt this, we're going to use a command called, pay in mind that this is in plain text right now. We're going to use the Ansible Vault command and then encrypt, and then the file name secrets. Now when we press enter, it's going to ask us to create a vault password. So we will go ahead and create that. And that can be anything. Okay, and now it says encryption is successful. Right? So now, if we try to cat the secrets file, this is what we get. Bunch of gibberish. So it's encrypted using AES 256 as an encryption algorithm. So we can't see this file on the server. All right, well, how do I make sense of this now? How do I add this here where I've got, you know, the inventory file and the playbook that are still have it in plain text? So now, the way we would do that is we would go back to our playbook, and there's something called a variables file. So if you go to Ansible documentation and you search for using variables, if you go towards the bottom, there's a section on defining variables and included files and roles. And basically all you do in your play is specify var files. So we're going to include that underneath hosts. We're going to go back to our playbook. We're going to pop it right here. And all we're going to do is include the secrets.yaml here. okay? So it's going to reference the secrets. Now granted, on the server it's encrypted, but here it's still in plain text. So what we need to do is, now that there's a variable file declared, now we can call those respective values as variables. And that's what we're going to do. So in the inventory file, we can just use Ansible user and Ansible password as the key name, and it will retrieve the value for us. And the way you do that is as follows. We would go to the inventory file, and rather than specifying the user, since the user is the variable, we're going to declare a variable here, or specify it's a variable. So double quote, double bracket, and we're going to add it like so. Hopefully that makes sense. So we're referencing the value that's in this file, okay, here. And we're going to do the same with the password. So we're going to copy this. I'm going to do a double quote with a double bracket, paste the value in, and add a space before and after. And now, this is something that could be uploaded to a repository, this file itself, because that's not really telling you anything. It's just a variable. So that's what we're going to do. We're going to modify the inventory file, and we're going to replace it with this. So we're going to go back to this. We're going to modify the inventory file. And rather than have this in plain text, we're going to delete everything that's in here. We're going to paste what we just worked on. Okay, so this is safe now to upload to a Git repository. You may want to safeguard the host, the private IP. It's up to you. You can do that too. But for now, the username and password is saved here. Now, we're still not done because the domain, if we write and save this out, the domain, if we cat the domain join, we still see the password and username here as well. So we have to do the same process. So what we're going to do is we're going to go to the domain join, and we have to remember, okay, the key name is domain admin user, and the value is here, and the key over here is domain admin password, and the value is there. So we're going to do the same process, where in the domain join, we're going to go over here, and we're going to use a variable notation, quote, double bracket, paste, before and after, add a space. And we're going to do the same. So we're going to add a double quote, double curly bracket, paste it in as a variable, and there you go. So there's nothing in domain join right now that is sensitive. Maybe the DNS server, you could also protect that as well. But I'm just showing you, we've got these 4 attributes and secrets, and now they're safeguarded and they're added as a variable file, and now we're referencing those variables in both the inventory, here are these 2 values, and in the domain join for the user and password. Okay. And if we look at the documentation, you'll see they use that same notation. The quote with the double curly brackets is referencing a variable. Okay? When to quote variables. Okay? So that's the notation. So let's, now that this is safeguarded, let's add this over to the Ansible server. So we're going to copy all of this, and we're going to replace it over on the Ansible server. So let's vi domain join.yaml, our playbook. We're going to delete everything here in the playbook that has the password protect in plain text. And we'll paste in this with the parameterized secrets. Okay, secrets.yaml, the var file that it's calling, and it's using those attributes. So let's save and write this out. So now, if we cat the secrets, it's encrypted. If we cat the inventory, there's nothing that's really, other than the IP address, there's nothing that, in terms of credentials, that is in plain text anymore. So that's safe to upload to a Git repository. And if we cat out the actual playbook itself, same thing. Other than the DNS server, which could be safeguarded, the actual username and password is safeguarded now. So you could upload this to a Git repository. So now that everything is safeguarded and Ansible Vault, now we should be able to run the following command, and regardless of the secrets file being encrypted, Ansible will be able to read it because what's encrypted is passed as a parameter. So Ansible playbook domain join.yaml is the name of the playbook. We'll specify I and then the name of the inventory file. And then we're going to add an extra option at the end because we are using Ansible Vault. So ---- ask vault pass. It's going to ask for the vault password, and it'll run through the playbook and perform the domain join. I did spin up a new server just to show you that even though we're using encrypted, oh, see, it's able to read it just fine. But even though we're using encrypted values for the usernames and passwords now, it can still handle it and understand it. So the secrets, obviously, you would not have that go up to a Git repository, that file that we just created, but now the inventory file and the playbook itself, other than potentially including the IP address as well, can be pushed to a Git repo. So we'll wait for this to complete. Make sure we blow away that old DNS entry for the computer name. I tried to do that real quick. Joining host to lombardi.local. Let's click refresh. Yep, there it is. It's there again. So this should succeed. And it did. So we are using Ansible Vault to safeguard those credentials, and the playbook can still run. Let's say you want to apply this playbook to dozens or hundreds of domains that all have different OU paths, that all have different usernames, right? And that the host name is going to be different. So can we parameterize that and add that as a variable file? And the answer is yes. And we'll do that right now. I think this is a good way to wrap it up, just to show you the power of how flexible Ansible can be. I know this video is a lot. There's a lot to set this up, but once it's set up, and when you're dealing with, you know, dozens or hundreds of domains, or, you know, dozens of OUs or different users, that's where this can really shine, is how flexible it can be. So very much like how we created the secrets variable file, we're going to do the same over here and create a new file called vars.yaml. Okay, and let's figure out what could vary. Let's say the domain name is going to vary, so we'll add that over here. Okay, let's say the host name could vary. Let's add that over here. And let's do one more. Maybe the OU path is going to change a lot. So we'll copy that over here. Okay, maybe this is named differently in different places, the host name. So it's name here and it's host name here. So we're actually going to call this host name. Okay. So now all we do is, it's the same principle, really. If you watch the previous section on the variables file related to password vault, we just copy the name of the key name, and we go into our domain join playbook, and now we're going to specify vars.yaml as a variables file. And now, wherever we see host name, it's going to be the same process. Double quotes, double brackets, the name of the variable. Change the host name to blah, because that's going to change. And then we're going to use the same variable in two other places. It appears here. And actually, Visual Studio Code actually highlights the other places where it appears. So there and there. Okay. And then what else we got? We have the DNS, the domain name. That you could have dozens of domains in your environment. You can use the same playbook if you code it correctly. So we're going to do the same thing here. The DNS domain, double quote, double bracket, and the variable name. And one more, the OU path. So we're going to grab the OU path, and we're going to go back to our playbook. We're going to do the same exact thing. Double quote, double bracket, the name of the variable, front and end space. So now, I mean, really the only thing that's not parameterized here is the DNS server. And you could even do that. You could parameterize the DNS server. But I think that's good for now. So what we'll do is we will create a vars.yaml file over on the Ansible server. So we're going to do a vi vars.yaml. And we'll copy the contents of this over here. And none of this is really sensitive, and this is subject to change. It's a variable. The OU could change, the domain could change, and the host name will change. So we'll write and quit that. And we also have to modify, since we made some changes to this domain join, we added the vars file under here. And we made a few changes to some of the values over here. We're just going to copy the contents of this file, and we're going to replace it. And now we're just going to modify the domain join playbook, and we're going to replace it all. And there we go. Nope, everything's parameterized except for the DNS server, and you could do that too if you wanted. Yeah, and we'll save and quit this. Now the moment of truth. If we list the files, we have the secrets, we have the vars, we have the inventory file, and we have the playbook. If we try to rerun the play, Ansible playbook, the name of the playbook, -I, the name of the inventory file, ask vault password, does this still work? There should be no changes because this is still the same server that we did last time with the secrets section. So we enter the vault password, and there it goes. It's able to understand the variable file and the encrypted file. So a lot of these are going to come back as green. And that's a wrap. I think that given the nature of this video being more than 3 hours long, this is a good place to stop. If you have watched this far, thank you. I appreciate it. I spent a lot of time on this. But the next video is going to be on, or part 2 of this video is going to be automating everything that we just did. The only things that we've automated in this video, really, were creating the VPC through CloudFormation. And by the way, we're going to use Terraform in the part 2. So there will be a section on how to convert CloudFormation to Terraform that will be included in the next video. And then the only other thing that we automated was the Ansible tool itself. But we could still call a playbook from a pipeline, so we could further automate that. And we'll cover that in the next video, but this is long. I figure this is enough knowledge to kind of give you some background on things that I've been working on. And thank you for watching. Stay tuned for part 2.